Vanishing/exploding gradients. A difficulty found in training artificial neural networks with gradient-based learning methods and backpropagation. Gradients can become exceedingly small or large, preventing the network from learning effectively. FC interpretation. Model gradient propagation as a dynamical system. The instability is a chaotic divergence. Apply FFC-stabilized matrix multiplication, circle times, to the Jacobian product at each step. This acts as a renormalization flow, axiom 18, keeping the norm of the gradient within bounded, computable limits. Example lambda term. A stabilization parameter epsilon in the FFC-stabilized matrix multiplication. Strictification. The instability can be gauged away by reparameterizing the network layers. Gemini, FC analysis. The vanishing/exploding gradients instability, a pervasive issue in deep learning, is conceptualized within the Polymath AI/FC framework not merely as a numerical artifact, but as a breakdown in the system's inherent informational dynamics. It represents a chaotic divergence in the gradient propagation flow, which the FC paradigm addresses through a sophisticated interplay of specialized mathematical operations, adaptive parameters, and topological diagnostics. Here's a deeper analysis. FFC math for stabilization. The core of the FC intervention lies in the application of FFC-stabilized matrix multiplication, circle times. This operator is not a simple numerical trick, but a fundamental redefinition of the matrix product within the FC computational algebra. It inherently incorporates renormalization flow, axiom 18, ensuring that the norm of the Jacobian product at each compositional step remains within a bounded, computable range. This directly counters the pi del h_/del h_ problem by providing an axiomatic guarantee asterisk of gradient magnitude stability. It transforms the ill-posed problem of unbounded Jacobians into a well-posed, computationally stable sequence, ensuring information, gradient, is neither lost nor amplified disproportionately.